The newsvendor model is a mathematical model used in inventory management. It's perfect for when goods are seasonal or perishable, which means that they can only be sold during a certain season or period and thereafter cannot be sold anymore. It's a single period problem, which means that a new ordering decision can be made in every period, but ordering can only be done once per period, namely at the beginning, when the demand is still uncertain. The price is fixed, and we do have overage and underage costs if we order either too many or too few items. Ingrid is the shop owner of the small gift shop called Schön und Schräg in Einsiedeln. For the Easter period, she wants to sell milk chocolate bunnies, dark chocolate bunnies, and white chocolate bunnies. However, she has a capacity constraint of 20 items, as she doesn't have a storage room and all the items she orders are displayed in the shop immediately, where she can only place 20 bunnies per season. In the multi-item newsvendor model, we have three different categories of chocolate bunnies: the milk chocolate bunny, the dark chocolate bunny, and the white chocolate bunny. All three different bunnies have different mean demands and different standard deviations, as you can see here. Additionally, we also know the unit cost and the sales price and other values. For example, the unit cost is 24 francs 90. The sales price, the price at which Ingrid can sell the bunny, is 36 francs per unit, and the salvage value is 8 Swiss francs per unit. This means that we have underage cost of 11 francs 0.1 and overage cost of 16 francs 0.90, and this gives us the critical ratio of 0.4 and additionally the Z value of negative 0.26. What you also have to keep in mind is that Ingrid only has limited capacity in her store. She does not have an inventory, so she shows all the bunnies she has in her display. And she only has space for 20 different bunnies. This means that we have only a maximum capacity of 20 units. Using this information, we can calculate the optimal order quantity for each of these different chocolate bunnies. So in the case of the milk chocolate bunny, for example, we take the mean average demand for the milk chocolate bunny, add to this the standard deviation times the Z value, which is the critical ratio in this formula. And in this case, we would get 11. Using the same formula for the dark chocolate bunny and the white bunny, we get a total quantity of 22. However, as we know, the maximum capacity is only 20 units. This means that we cannot order 22 bunnies, as we would not have the space in the store. So what we could do is scale it down. So we can take the value here for the milk chocolate bunny of 11, divide it by the total quantity, which is 22, and multiply it by the maximum capacity to get a scaled down version, which would be 10, 5.77, and 4, which would in total give us 20 if we round it. However, what we don't take in mind is that now all the different optimal order quantities have different Z values. However, this would be wrong, given that the Z value is based on the critical ratio, which is the same for all bunnies. So even with the new numbers, the Z values need to be identical for all three different chocolate bunnies. So to get values which all have the same Z value, we need to get a bit complicated and use a bit more complex formula. So we're going to use a formula called goal seek. And what we first have to do is we have to add all the optimal order quantities together. This means that we take here the mean demand for the milk chocolate bunny plus the standard deviation for the milk chocolate bunny times an arbitrary value, which here is the Z value, and we just put in 1. It can be 2, it can be 5, whatever. And we do this for each different chocolate bunny. And then what we do is we go on the data, what if, goal seek, we set the cell N7 here, which is our formula, to the value 20, so to the maximum capacity we have in our store, which we have here. And we want to change this by changing the cell here N8, which is the Z value. So we press on OK, and we find out that the optimal Z value is negative 0.67. And as you see, we get a maximum capacity of 20. So using this Z value, we can now finally calculate the optimal order quantity, the correct one, for the different categories, using the mean demand plus the standard deviation times the correct Z value. And as you can see, all three bunnies have the same Z value, and we get a total of 20 units. Now, using this information, we can calculate the costs per bunny and also in total using the formula here. So adding the underage and overage cost and multiplying it times the standard deviation and also this formula here. And we get total cost of 53.7. And now that we have the cost, we can finally calculate the profits using the normal profit function. So we take the unit costs, we take the sales price, subtract the unit cost, multiply it times the mean demand, and then subtract the total cost. And as you can see, we have the profit per different category of chocolate bunny and the total profit of 212.736 francs.